me start recording. Okay, good. Okay, then let's get started. Let me download this file. +2. Okay. Now, first I will show you the hand calculations and then I will move on to MATLAB. Okay. So you will be writing your name, your section, your date. And then problem 1, it's a direct formula. Okay. You just have to integrate this. Use power rule, integrate each part. Okay, each part, you'll get the answer. So let me straight away go to problem 3. Okay, problem 3. Now, we had studied finding area from lab 1, lab 2, right? Now, what's so difficult here? The difficult part is you have a multiple functions, right? You have a multiple functions and there is no domain, or I can say limits, right? Limits are not given directly. And they are also not telling you which part you have to find the area, right? This is empty. So you have to fill the graph first because you need to find the part where you need to find the area. That will give you the limits. Okay, how can we do this? Okay, let me start from here. X equal to 3. Where is that? 0, 1, 2, 3, right? X is 3. Now, x equal to 1. And then x equal to -1, which is here, -1. Agree. Now, for x equal to 3, how does the line look like? Equation of the line, right? It's vertical. Because here, when x equal to 3, y is 0. Y is not given, so we will take it as 0, only for this part. Now here, this is also a straight vertical line. Sorry, I'm not so accurate while drawing. Okay, right? So this is over, this is over. This is done. Next part is this. So if this function looks little tough, so let me draw this and then I will move on to the next part. Okay, now y equal to -x. Y equal to -x. So at x equal to 0, what is y? 0, right? So at x equal to 0, y is also 0 for this part. Now at x equal to 1, y is -1. Agree? So x equal to 1, y is -1, which is here. Again, start doing this all the way up to the end. So x equal to 2, y is -2, right? And so on. Okay. Now, what happens when x is -1? Y is +1, right? Because negative of -1 will give you +1, right? So this is +1. Likewise, if you keep going, you will get a straight line. This is how you will identify the shape of the graph. Okay, I will connect this. Okay. Now, next function is this, y equal to half x minus 3/2. Now, You can do like you did for y equal to negative x, taking x equal to 0 and finding what is y, and then x equal to 1, what is y. You can keep doing that. Or at x equal to 0, what is y? Negative 3 half, right? Just plug in x equal to 0 here. The first term is 0. You are left out with negative 3 by 2. Okay. Now, what happens when y is 0? X is, anyone? You just have to plug in y equal to 0 here and solve for x. So you have a formula here. No. Negative 3 half is for y. So half x minus 3 over 2. But thank you for answering. 3. No. Okay. This is 0. So this is 3 half. And half into x4. Alejandra, that was right. So Alejandra gave me a right answer, where x is 3. Okay. I will show the calculations here. You can make a note of it very quickly. Y equal to half x minus 3 over 2. What I told you was plug in y equal to 0 here and find what is the value for x. Right? Now I'm going to send this constant to the other side, or you can send half x to the other side. Anything is fine. So 3 half negative moving to other side becomes positive. So 3 half equal to half x, right? Now you can cancel out 2 here. You are left out with x equal to 3. Okay, you can make a note of this if you want to. Okay, now we have 2 points here, right? Now I am going to put that point on the graph. So x equal to 3, I have it here. And y is negative 3 half. So negative 3 half is 1.5. In decimals, it becomes negative 1.5. So it has to be somewhere here. Let me give it here. Okay. Negative half. Now, what you're going to do is you're going to join these 2 lines. Join these 2 lines carefully. Got it? Now, you have a intersection point. At what point is it intersecting? What is the x point here? Anyone? This is negative 1. This is 0. This is 3. And what point is this? Very good. It intersects at 1. Okay. So that is your intersection point. So intersecting at x equal to 1. This is very important. You will know why. Okay. Now the graph is done. This is what you have to do. Okay. So first part, when you're doing graph, you have to plot all the functions given here. Got it? Now, if you think doing all these things, if you're getting confused in the entire thing, and if you do not know the shape of the graph, you can always use MATLAB. Okay, I will teach you how to do this in the MATLAB as well. But this is like a traditional way, so we follow that. Okay, so first thing is plotting all the functions on the graph and then finding the intersecting point. Okay, you have to find the intersecting point. That is very important. Now, this is one way of finding intersecting point using graph. Okay. Now, sometimes while you are doing a rough figure, you might not know the exact intersecting point, right? So we need to calculate it. So how do we do that? So to find intersecting point, this is second way of doing intersecting point. You have to equate the functions. You have to equate the functions. Okay. Now, how many functions do I have? I have two functions, right? Y equal to negative x, y equal to negative x, and y equal to half x minus 3 by 2. So y equal to negative x, equating means you're going to just put equal to sign and then write the another function here. Okay. And then you're going to solve for x. Solve for x, and whatever value you get at the end for x, that is going to be your intersecting point. Now, what will be the value for x after solving this? I mean, it's a very easy question. Okay, negative x, pulling this half to the other side, negative half x equal to negative 3 by 2. I'm keeping the constant on the one side. Now this, negative 1, negative half. Taking LCM, everything, that will give you 3 by 2x, right? And this is negative 3 half on the other side. Now you can cancel out, right? So that will give you x equal to 1. Okay, this is the second way of doing. If you're not confident of the intersecting point that you found using the graph, you can always use this one. Okay, equating functions will always give you the right answer. Got it? Okay. All this is about only sketching the graph. Got it? Okay, I will give you 2 minutes to just take this down. I'm going to erase everything because I need some space to write the integral function. So please make a note of this. You can just take a picture as well if you want to. Okay. Um, can I erase this? Is anybody making a note of this? Thank you. Okay, so first part is done. Setting up the graph, sketching is done. Okay, beautiful. Now, MATLAB code. I will come to this after I do the third step. Okay, now write the solution by step, right? So what do they mean is that you need to find the area by hand. Okay, find the area. Now, what type of functions do we use? Like, I mean, do we differentiate or do we integrate to find the area? Do we use integration or differentiation while finding the area? Okay. Remember, finding area is like summing up, right? You're going to sum up everything, all this part. Remember the first lab, you're going to add each and every space here, and that will give you the total area. Okay. Whenever you have a concept of summing up, that means you are going to integrate. When I mean differentiation, that means you're going to divide it, right? Divide. So here you are not dividing, you are summing up. You are summing up each part to get the total area. So we are going to integrate. We are not going to use derivatives or do the differentiation in finding the area concepts. Okay, we are just going to use antiderivative. Okay, now we have two functions here. So I'm going to write two integration functions here. Now we know that I have a graph here, right? Now what part should I find the area? That's the question. And because of that only we did the graph, right? We need to know what part do we have to find the area. So this is the part which I'm going to find the area. Okay, the shaded region. Now the boundary, so this is the boundary. Okay, this one is the boundary. So this is the shape of the figure which we are going to find the area. Let me shade it properly. Okay, so this is the boundary part. Now, remember, in order to find the area, we need to have a certain shape, right? But what can we do here? We have something like X mark, right? So we do not have any standard formula to find this. So we are going to use integration. That's fine. Now, how can we use integration here? Okay, so here we can consider this as a rectangle. Okay, and now considering this as a rectangle, now I'm going to eliminate the top portion and the bottom portion. You have to be very careful when you are doing this. So this is y equal to negative x, and this is x equal to 1, negative 1, and here x equal to 3, the line which is here, and this diagonal is y equal to, I'll just write it as a second function, or y2, okay? y2 is this one. Just note it down like a y2. Okay. Now, this is the formula. When you have this type of area, this is the formula. Top minus bottom, because I need to subtract these two to get this. This is the entire rectangle. I am going to subtract top and bottom, both. Okay, top minus bottom into dx. And again, same thing, but we are going to add. Remember, adding top minus bottom into dx. Yes, Joseph, you are exactly right. You are going to find area between -1. This is -1, right? This point here is -1. So -1 to 3, right? Agree? Because this is 3. -1 to 3, and here, what limits are you going to put? It is going to be 1. Why? Because that's our intersection point. So you are going to find area from -1 to 1. Okay, that's your first part, because that is where you are going to intersect. So first you will find this area, and then you will move on to the other thing and find the next area. Okay, now integration -1 to 1. What is the top line? What is the top function here? We are just solving the first part. So what function is this line? Very good. It is -x. Okay, top function is -x. Negative, because we have negative here. And then we are going to do the bottom line, right? And what function is that? Very good. That is going to be y2, and the y2 function is half x minus 3/2, right, into dx, plus from 1 to 3. Now this part. So 1 to 3, top function will be y2, because remember, for this part, this is the top function. This is the bottom line. So y2 half x minus 3/2 minus bottom is -x into dx. Okay, very easy, right? Okay, now we are going to simplify this. -1 to 1, -x, negative half x, that is going to give you 3/2 into x, and then positive, because minus into minus is plus, 3/2, and then you're going to integrate this function, right? Plus 1 to 3. Now half x plus x will give you positive 3/2 into x. Again, minus 3/2 into minus 3/2 will give you minus 3/2. Okay, into dx. I can elaborate this if you want to. This is minus 3/2 This is going to be plus x, right? So we are just going to add these two and leave this negative 3/2 as it is. Okay. Now you have simplified everything. You are going to apply the power rule. Okay. So how did this becomes this, right? Let me show it here. Okay, negative x, negative half x minus 3 over 2, right? This is what we have. Integration from negative 1 to 1 dx. Okay, now keep this as it is. Negative 1 to 1, negative x, multiply negative inside. So that becomes negative half x, negative into negative is positive 3/2. Remember, do not multiply x. Okay, this is a subtraction, not a product. Got it? Okay, into dx. Negative 1 to 1. So since we have a like terms, because we have x here, we have x here, that will give you negative 1, negative half. Taking LCM, that will give you negative 3 minus 1 divided by 2. Negative 2 minus 1 divided by 2, right? So this is negative 3 by 2. And that is why I will write negative 3 by 2 x, because we will have x here. And then we cannot add or subtract this with anything. We do not have any terms left. So I will write it as it is. That's how we get this. Okay. I will wait until you guys make a note of this. Okay, let me erase this. I'll get some space here. Okay. Okay. Now that we have simplified, you can apply the integration, which is the power rule. Okay, you know the power rule, right? X to the power of n, integration dx is equal to x to the power of n plus 1 divided by n plus 1. Remember? Okay. Now, I'm going to apply integration for this first, this one. Now, this is negative 3/2 x to the power of n plus 1, right? So, x square divided by 2, right? Plus integration of a constant, any constant it might be 1, 2, 3, 10, 100, anything. Integration of a constant is just x. Okay, So this is a constant, right? Now you're going to integrate that. So that will give you a constant. Okay. Oops, I have to write the constant as well. So this will give you constant. Okay. Done. So what is the leftover part? We have to apply the limits that is still there. We have to apply the limits. This. Okay, plus use the same formula for this one. Okay, 3 by 2 x, which is similar to this. You just have a negative positive. So that will give you 3/2. You have x, integration of x is x square divided by 2. Right? And then negative 3/2. Since it is a constant, you will get x. The dx will be removed immediately once you apply the formula, and then you still have a limits to apply. Okay, understood till this part? Okay, now let us move on to applying limits. So remember, when you are applying limits, it has to be upper limit first, and then you're going to subtract and then apply lower limit. Okay, upper limit first, subtract, lower limit. Okay, let's do the first part first. So this is negative 3/2. So when I say applying limit, that means you're going to plug the limit value in place of x. Okay, just plug in. Okay, open braces. We have 1. I'm going to start with upper limit. This is upper limit, right? This is lower limit, right? Okay. I'm going to start with upper limit first. So 1 by 2. 1 square is 1. So I will just write it as 1 plus 3/2 into 1. Okay. Negative, because we have negative here. And then lower limit. Apply lower limit to the x part. You have to apply limits for each term, not first limit for the first term, second limit for the second term, not like that. Do not do that mistake. Each number you have to apply it for each term. Okay, next part is negative. So I will open a parenthesis, big parenthesis. This is negative 1, negative 3 by 2 multiplied with negative half. This is positive because negative 1 the whole square will give you positive, plus 3 by 2 into negative 1. Okay, and then you're going to apply a parenthesis here. Okay, this is the first part. This is only for this. It is quite lengthy, but if you understand, it is easy to do. Okay, now we are going to do the same procedure for the second part. Okay, upper limit first. So 3/2 into upper limit is 3, which is 9 by 2, minus 3 3s are 9, because we will get, let me write like this first. Okay, this is upper limit minus open parenthesis lower limit. 3/2 into 1 over 2 minus 3/2. Okay, this is for this, this is for this. Upper limit minus lower limit. This is upper limit. This is lower limit. Again, upper limit, lower limit. Okay, now you are going to simplify the whole thing. So simplify the whole thing and tell me the answer. Take your time. It is just a simple math. But be careful with the negative sign. Hmm. Hannah Wink. That's not the right answer. But thank you for answering. Make sure you're taking the negative signs properly. Okay. You might have made mistake with the negative, multiplying the negative sign. Mm, no, 0 is not the answer. 3 over 2, no. Okay, let me do it. But meanwhile, you guys please keep working on this. Let me see who gives me the right answer. Okay. Minus 3 by 4 plus 3 half, right? Again, minus multiplied inside plus 3 by 4 plus 3 half, because negative, we have negative here, so negative, negative, plus, plus. 9 3 is a 27 by 4, negative. 9 by 2, negative. 3 by 4, positive. 3 by 2. Negative 3 half here, these two get cancelled. We have 1, 2, 3. 1, 2, 3, 3 halves. That will give you 9 by 2 plus 27 by 4 minus 9 by 2 minus 3 by 4. 12.75? No. Okay, so these two get cancelled. 24 by 4, right? 27 minus 3 is 24. So 24 divided by 4. Now tell me the answer. What is 24 divided by 4? The answer is 6. Okay, this is the answer you have to get. So I really appreciate for those who gave me the answers. I really do. Make sure that you're taking a negative signs properly. Okay, see, you have a negative here, right? So this will be negative 3 over 2. But when it comes outside, this becomes positive because you have negative again. So make sure you take a negative signs properly. Okay. Now, I know that I got so many answers, but I was there to correct you, right? Now, if you are doing another like other problems, but you do not know what is the right answer, how can you verify that? That's why we have a MATLAB code here. Okay. The answer you get in the MATLAB code and the answer you get by hand has to be same. Okay. It has to be same. Keep that in mind. So that's your problem 3. Okay. Now, I will teach you how to do this in the MATLAB as well. But before that, let me do problem 5. Okay. Shall I move on to problem 5 or do you want me to give you some time to make a note of this? Okay. Now, problem 4 is similar. Okay. The only difference is in this problem, we had y as in terms of x, right? We have y as a function, x we just have a number. But when it comes to problem 4, we have x as a function of y, but y is just a constant. Okay, that's the only difference, but the procedure is going to be same. Even the formula, okay, formula as well is going to be same. Okay, now let me go to problem 5 because problem 5 is finding the volume. Because when it comes to finding the volume, the formula is going to be different. Okay. Okay. We also have a hint given here, so we can make use of this. I have taught you this identity formula in lab 2, right? We We learned this while solving problems. Okay, now what do we have? We have y equal to tan x, we have y equal to 0, x equal to pi by 4, right? Okay, x equal to pi by 4. Where is that? So we have pi by 4 here. So x is pi by 4. That means we are going to have it here. Then it has to be a straight line, right? If x is a constant, then that is going to be a straight line because at that point y is 0. Okay, okay, this is done. Y equal to 0. Y is 0, and that is going to be a horizontal line because y is 0, so it will not be a vertical. Okay, now what about y equal to tan x? Now this plot from 0 to pi by 4, it looks like a cone shape. Okay, it is similar to a cone. Okay, you can check back in your lecture notes. I think this problem might be solved. Okay, so this looks like a cone in a 2D plane. So let me draw that here very roughly. Now I'm not going to draw it out of this line. Okay, you're not going out of this line because this acts like a boundary. So your figure should not move or should not cross this figure, cross this line. Okay, so you have a cone here, right? You will have two radius, inner and outer radius. Okay, because when you have a cone, your inner radius from here to here is different, and the outer radius from here to here is going to be different, a slight different. Okay, because it's not a cylinder to have an equal radius, it is a cone. Okay, now keeping that in mind, remember we have two radius. Now, what will be the volume of the cone? Okay, using the formula of a volume of the cone, we are going to build up a formula for the integration. Now, pi r square, right? Remember the formula, right? Pi r square. Now we are going to use the same thing, but in a different way. So I will keep a pi outside because it's a constant. So let us not take it inside. Integration r square minus small r square into dx. Now what is this r and small r? So here capital R is the outer radius of the cone. Okay, outer radius. So I'm subtracting from the outer radius. Assume this as outer radius. Okay, from this outer radius, I'm going to subtract this part, a smaller radius, which you find it here. Okay, I'm going to subtract from outer radius, I'm going to subtract the inner radius so that I will get the area under the curve. I need this area. Okay, fine. So that's why I will write capital R minus small r. So small r is inner radius. Okay, fine. So V is equal to pi integration. Oops, I forgot to write the limits. Okay, anyone, what might be the limits from the graph? Let me erase this. Any idea what might be the limits? Very good. It is going to be 0 to pi by 4. Why? Because we know that this point is pi by 4 because it's given here, it's pi by 4. But how did we know it is 0? It is 0 because we are going to start from 0, right? We do not have any shape or any area to find behind 0. Okay, and that's the reason we are going to start from 0. Not because y is 0, that's because we do not have the cone outside the origin. Okay, now pi 0 to pi by 4. Now outer radius is given by tan x. Then what is the inner radius given by? Inner radius will be 0. Okay, we have two functions where this is the capital R, this is the small r. Got it? Okay, now capital R is tan x, so I will write as tan x the whole square because it is capital R square minus 0 square is 0, so I'll just write it as it is with dx. Okay, equal to pi 0 to pi by 4, the same thing. Now you are going to use the formula here, okay, because we do not have a standard formula for integration of tan x the whole square. Okay, so we are going to use the identity and then simplify the integration. Okay, so using this identity, now I have a formula for tan x the whole square, right? That is secant square x minus 1 into dx. I will not write this 0 because you don't have to do that. Now you can ask me, why can't I write like this? 0 is a constant, right? But when you multiply 0 into dx, it just gives you 0, right? If you do not have dx next to the 0 or next to the anything, you cannot integrate the function. Okay, and that's the reason we have 0. Okay, now equal to pi 0 to pi by 4. Let me write the formula. Okay, now integration of secant square x. What is the formula? Dx. It's a standard formula. I guess you must have known. What will be the integration of secant square x? Very good, very good. That is going to be tan x from 0 to pi by 4. Right? So let us write tan x here because integration of secant square x is tan x minus, we have a constant 1, right? So integration of 1 is x. And we have a limits that is 0 to pi by 4. Okay, now what you have to do is just apply the limits and find the area, find the volume. Okay, I will leave that part to you. So tell me, what do you get after applying the limits? Remember, you have to take 0 as well. Tan of 0 and minus 0. You have to take 0 as a limit as well. Do not leave it as it is. Okay. I will also simplify, but you can do on your end without seeing my calculations so that you will have a practice. Okay, so first thing is upper limit tan pi by 4 minus pi by 4. Okay, upper limit minus lower limit, that is tan of 0. Tan of 0 is 0 minus 0. Okay, so volume is pi. What is tan pi by 4? Yes, tan pi by 4 is 1 minus pi by 4 minus tan 0. Right? So 0 minus 0, that is going to give you 0. Now the final answer is pi times 1 minus pi by 4. That's the volume. Okay, that is going to be your final answer. I know it's a huge calculations, but you need to practice it really well. Now, like, I guess we took maybe 1 hour to do these problems, but I will show you how to do this in MATLAB, maybe in 5 minutes. Okay, it is just 3 lines of code. Okay, but we still recommend you to do hand calculations. Okay. Do you want me to hold on or can I move on to MATLAB? Okay. Okay. So before I do that, let me give you some hint. Okay. So problem one, I mean, it is not too difficult. It is just a direct integration. Okay. Direct integration. Now I know it is a bunch of formula. So it is like x cubed 2x minus 3. So you might be wondering how to plot the graph. You must be getting only one line. Okay, I'll show you how to do this in the MATLAB. Okay, you can just sketch the same plot roughly on this paper. That would be fine. Now this is your MATLAB code. Just 3 lines of code is equal to 1 hour of hand calculations. Okay, next is problem 2 is similar to your problem 3. Okay, you have two functions, two constants. You're going to plot that on the graph here and find the region where you're going to, which part you're going to find the area. Then you will have two integrations. Okay, and then you will find the final answer using both hand and both hand calculations and the MATLAB code. Problem 3, it's done. And problem 4, as I told you, it is just a swap. Okay. And problem 5 is also done. Okay. So problem 6 is finding the volume. Now you have two functions, one constant. Now you need to find the volume, right? Finding area is quite easy. because you will have only one formula, so you can use that. But when it comes to volume, you will have a different formula for different shapes, right? So I will give you just a hint. You can use washer method. Okay, I will not go deep into this. You can take a look at your lecture notes if you want to. So the formula for volume must be pi r square minus pi r square. Okay, it is same as problem 5. Okay, remember capital R is your outer radius, small r is your inner radius. You have to figure out what functions will fit to the outer, what function will fit to the inner. Okay, now problem 7 is also finding area, right? I mean, sorry, finding the volume. Now, if you plot this, if you just take a look at this, it is y equal to x square. Here you have y equal to x square, same. And here you have y equal to root x. This is also y equal to root x. And x equal to 2, x equal to 2. Then what is the difference? Difference is you can use the same method. You will get the same answer, but they want you to use a different method. Okay, they want you to use a different method. Remember, I will give you a biggest hint. Problem 6 and 7, you have to get a similar value. Okay, if you're, let's say you are getting 100 here, you have to get 100 here, both in MATLAB and hand calculations. Just an example, okay? Okay, so when they say use a different method, what method can you use? Now, the thing is, when you plot this on the graph, you will get a cylindrical shape. Let me, to be specific, it will be like a cylindrical shell. Okay, now what will be the volume of that? It is going to be its circumference, which is 2 pi r. So circumference multiplied with its height and the thickness. Okay, figure out, this is a formula. Now you have to figure out how to use this inside this formula and find the answer. You must have done this in your lecture section. So just take a look at your lecture notes, so you will be good to do this by your hand. If not, even if you are doing these calculations, if you think it is too difficult for you, then you can always email me. I can give you some more hints, or I can tell you where you're going wrong. Okay, so I also have class tomorrow. It's a calculus 2. I guess it's in CCH 210 from 3:30 to 5:20. So if you have any questions, you can stop by. Okay, fine. So enough with the talk. Now I am done with the hand calculations here. So let me go and do this in the MATLAB. MATLAB here. Okay, text mode. And write your name section. Although you're not going to submit this a file in the Blackboard, okay? You're not going to submit this file. Keep that in mind. You're just going to submit this file, only this one, okay? Because here in the MATLAB code, you're going to write whatever code you have written in the MATLAB, like the one which they wrote here. Okay, so since I have the graph, the code, the answers, everything in the one page, I do not need this one additionally. Okay, clear? Okay, so let me get to the code mode here. Problem 2. Let me start with problem 1. Let me show you how to do the graph first. Okay, so problem 1, it is x cube plus 2x minus 3, right? So x cube f is equal to x cube minus 2x plus 2x minus 3. This is plus, right? That's the function. Okay, so one more thing, you're not going to use the dot product while doing integration, only while doing integration. Okay. Now, this is just like additional steps. Let me plot from, let's see, what is the interval 1 to 3. So 1 comma 3, let me give some under divisions. Okay, and then you can use PLOT x comma f, right? But to write dot product here because this is a vector. There you go. That's your graph for problem 1. Okay, so you can just take this as a reference, go back to your lab manual. Here you can just draw it, right? That's it. Just do a rough sketch. You have everything in the MATLAB. Okay. I'm not sure whether this can plot the trigonometric functions so properly because it's like a 2D plane. But when I plot tan x here, it will give you 1D. Tan of x. Look at this. You will get in a 1D array. So this is not similar to what I did just now, right? So trigonometrics, if you want in a 2D, you might not get it. Okay, that was problem 1. And problem 2, I'm going to write sims x because symbolic variable, so sims x, and then f is equal to negative x, right? We have another function that is half 1 over 2 into x minus 3 over 2. And a equal to, for integration, you are going to write int, okay? That's the built-in function in the MATLAB. So what is it asking? It is asking for expression, variable, name, and value. Okay, so first is we will write a function that is f minus g. Why is it f minus g? Problem 3. Okay, here you can see it is top minus bottom, right? So we are using this function, y1 here, y2 here. So y1 minus y2, function 1, function 2. I'm going to use the same formula there. F minus g, comma, -1 to +1. That's your limit, right? Plus int, integral, g minus f. You are going to use the same formula which you did while doing the hand calculations. And next is you are going to put the limit from 1, 3. That's it. Okay, I will just make this not visible in the output. Okay. Control enter. There you go. That's your answer, A equal to 6. Now, what did you get when we did hand calculations? We got 6, right? See, the MATLAB answer and the answer by the hand calculations is same. So this is how you have to get. Now, if you want to do for problem 5, this is problem 5. Since X. Now, you can name it as F and G again, but sometimes it might overload. Okay, it might overlap and use F and G as this one. So we do not want anything that to happen. So I'll just making a different notation. T equal to tan of X. That's the problem given. Put a semicolon. And then what is the next function given, which is 0. Let me keep it as R. Right? We had two functions, which was tan x and y equal to 0. I did that here. Now next is finding the volume, not the area, volume, right? So V equal to int integral of I into outer circle, that is R, capital R square minus small r square. Okay. If you're wondering how I got this formula, okay, how I got this formula, go back to your hand calculations here. You can see that I have used pi into integration. So instead of this line, I have int, and inside I have capital R square minus r, small r square. That's what I have written here. Okay. Now, comma, because I need to write the limits as well, which is from 0 to pi by 4. Okay. And then control enter. That's it. Minus pi into pi minus 4 by 4. Now the answer which we got was this. Now, if you're wondering the answer is not same, it is same. All you have to do is take LCM. This becomes 4 minus pi by 4. Multiply pi inside. That will give you 4 pi minus pi by 4. Okay? Fine. Now, okay. Let's see. Let me also do problem 7. We did not do the hand calculations, but I will show you how to do that. Let me apply a section break here. Okay. Syntax as usual, and this is for problem 7. This is for problem 7. Syntax and r equal to 2 minus x. It's a function given in your lab assignment. This is for problem 7, which we did not do in the hand calculations. Square root of x minus x square. Okay, it might not be the exact function which you see in your lab manual. You might have to do some modifications. Okay, that is completely left to you. So you must know what functions you have to use in the formula. And then you're going to find the volume, which is integral of circumference into height into thickness. That was the formula for problem 7, right? Using a different method. So circumference is 2 pi r. So 2 into pi into r into h. Okay, comma, limits are from 0 to 1. You can refer to that problem. Control enter. 31 pi by 30. Okay, so for problem 7, you have to get 31 pi by 30 when you do the hand calculations. Also, for problem 6, you have to get the same answer. Okay, because you have the same questions, you're just using a different method. So you must get a same answer. If you're getting like a decimal 31 by 30 and you are writing it in terms of decimal, that is also fine. But you have to get a correct answer. Okay, so that will be end of your lab 3. Okay, do you have any questions? I know the lab is too long.
So do we have to do the work on the sheet?
Okay, so you can take a printout of this lab manual because you have space here. So you can just write your hand calculations here. Or if you want to write it in a different sheet, that is fine.
But we turn it in on this sheet, right?
Yes, yes, this sheet is important. This is the sheet which you turn it in the blackboard.
Okay, thank you.
No, you do not have to submit the MATLAB code. Sure. What is the question? Is that related to assignment?
Yes, I just didn't know how to integrate tan on number 8 on the assignment.
Okay. Can you wait until everyone leaves?
Yes.
Sure. Yeah, MATLAB code. Yes, you must also learn how to use the integration in the MATLAB. So that's why you are learning MATLAB as well.
But for the last assignment, did we also have to turn it on like the sheet that was presented?
Exactly. You
But
have to turn it in the lab manual which you see. You have to turn it in that one along with your hand calculations.
what if I like copied everything in a sheet of paper? Would you accept that?
Yes.
Okay.
Oh, it's like you're writing everything in one sheet of paper.
Yes, like on a separate sheet of paper though.
Yeah, I get it. Yeah, that's fine.
Okay. All right. Thank you.
Mhm. So next time when you have some integration problem, you can just come to MATLAB, use int, find your answer. Okay, even if you do not have limits, it'll work. So int function is used for definite integral as well as for indefinite integral. Any other questions? Okay, so if you have any questions on assignment 2, I mean the lab 2, you can stay. If not, you are good to leave. Thank you. Um, Alejandra, was it question number 8?
Yes.
Okay. Okay, so what was your question on that? Like, do you have any?
I didn't know how to integrate the tan, because I thought like the integration of tan was secant squared, but it wasn't, because that's not what the final answer came out on the lab.
So you have, so you're stuck here, integration of tan x, right?
Mhm.
Okay. Now, we know that we don't have any standard formula for this, but we know that tan of x can be written as sine of x divided by cos of x, right? So we are going to use this formula here. Okay, sine of x divided by cos of x into dx. Now you're going to apply the u substitution again. So for problem 8, you will apply u substitution twice. Okay, one is to solve the problem and another one is to solve this tan x. So that's what I'm going to do here. I'll put u equal to cos of x. The notations which I'm using is different, so just be careful with that. Now this is du by dx. That will give me negative sine of x. From this, I'm going to write what is du, which will give me dx negative du by sine of x. Now I'm going to plug that here. Integration. Sine of x is not given, so I will keep that as it is. Sine of x divided by cos of x is u. Dx is negative du divided by sine of x. Now I'm going to eliminate this one here, here. That will be equal to integration of negative 1 over u into du. Now the integration of 1 over u is log of u. We have that formula. So integration of 1 over u is log of u. Let's see. We know that. So I will keep the negative sign to the outside. I will write log of u. Let's see. Okay. Now what is u? U is cos x. So negative log of cos of x. Let's see. Okay. So the integration tan of x, the formula is negative log of cos of x is c.
Okay, and then after that, you plug that one in into the equation,
Yeah.
and then you do u sub all over again.
Oh no.
Or
You
no?
don't have to. You don't have to do that again. So remember, your value must be like this: negative 1 over 3 log of cos x cube because you would have to u as x cube in the first part. So this has to be the answer for your question number 8. Negative 1/3 log of cos x cube plus c.
Okay, because like on the for the final answer, they use the ln secant. Or no?
No, you don't
That-
have to do the secant one.
Oh, so it's basically the same thing?
Yeah,
Oh, okay. That's what I was confused on.
yeah. So this is the solution you have to get for question 8. The same thing.
Okay, thank you.
No problem.
Goodbye.
Goodbye. Justin, do you have any questions?